Alright, welcome back to another episode with BIM2K. For today's subject, we're going to talk about a very sore subject of mine, one that caused me a lot of pain and grief throughout the years. This was a huge annoyance for me during the project, just because working on the construction management side, I often ran into this problem. Now, I don't like to have this problem, and I think a lot of us don't like to have this problem. And the main reason why we don't like to have this problem is because it's reoccurring during a project. So that means if the problem occurs in the early stages of the project, chances are it's going to follow you throughout the project. So the problem is these famous columns that spans a lot of floors. So for a long while, I used to fix this by copying the clipboard and then pasting the same place. And then I used to copy multiple copies of this. And then I would attach the base to the correct floor and the top to the correct floor. And I would just go downwards like that. However, this became a huge annoyance in one of the projects. And the problem was, no matter how many times I've mentioned it, the structural engineer didn't want to necessarily change this, just because there was some benefits for them to use this type of template. They wanted to move a column, they wanted all the columns to move, things like that. Not that the line tool doesn't exist, but what can we do? So often ridden with this problem, project after project, I decided that I was gonna put a stand against it, and therefore I had to create a script. So there is the hard way of doing this, and obviously I don't like doing things the hard way. Just it's long and tedious, and I gotta do this for every column possible. And in addition to this, every time there's a new release, I get to have the same issue. And the major obstacle in me accepting these was, once, for quantification purposes, it caused me always a lot of problems because I wouldn't be able to necessarily split this by level. And the second part was scheduling. So if I wanted to do a 4D schedule, well, I needed to break these into sequenceable parts. So meaning on site, it's going to be sequenced in such a way that we're going to pour one floor at a time. So obviously I needed to show this part. I mean, there's workarounds, there's all these things. And I want to take a bad project. I call this a bad project just because everybody would assume that these are the survey elevation, but they're not. There are actually local coordinates. For some reason, the company used this as a project base point, and this is why we see this elevation 0 at 50. Very unfortunate. The project is basically flying up in the air. But nevertheless, we're going to fix this issue. And like I said, I've navigated throughout this world to see if there was a better tool for this and potentially something that can accelerate this. And finally, I decided to rest my soul with Dynamo. Dynamo was able to fix this to some extent. So we're going to create this together. And the way that I like to do this is I'm going to place them side by side. So obviously I like to visualize things, and I want to be able to do certain components at the same time. It does provide me with an, flexibility and a 4K screen, having that real estate really to kind of visualize all of this at the same time and to work one beside the other. And often I have to select things within my model, so it comes in handy. So that being said, let's just go create these things. So basically what we have is we have a column, and it's spanning across multiple floors, as we can see. They are structural columns, so we have a base level, we have a top level, and I want to play around with this. And at the same time, we have a lot of levels. So basically what we want to do here is we want to select one item, and we want to select all the levels and see which one intersect together. So this would be a good way to tell us, where we want to split this column down the line. So that being said, let's just go through the basis of building this out. Let me just expand this slightly. So going into Revit, we're going to select all elements of category. Once we do this, we're going to select the categories. Oh, my apologies. We're going to select the categories levels. So obviously once I do this and I run my script, you're gonna see all my level, and they usually take a good fashion, so they're going from bottom to top, which is okay. In this game it makes a lot of sense. We'll use this to our advantage later on. So once we've selected this, I want to be able to extract the elevations of these. So we have an elevation marker here. We can tell 55,000, 57,000, 58,000. So we have a lot of valuable information. In order for us to extract these elevation, we're going to go into level, elements, we're going to go into levels, and I'm going to extract the elevation. So the elevation of the level above the ground level. If I do this and I extract my elevation, you can kind of see we've extracted all these levels. So this is going to come in handy later on. Once again, there's going to be a lot of benefits. Lastly, what I want to do is I want to select also. I'm going to do this on individual level, obviously. But later on, I could interact with this in a more strategic way. So I could select all my columns. But for the sake of argument, I'm going to select only one. So what I'm going to do is I'm going to select one model element. So it's going to be a lot easier to kind of follow this discussion. So once I select this, I'm going to select my column that I've chosen here. I like this one, it's a round one. And we can kind of see that I've selected it. So when I go, I can see that I've selected my column and this and that. So once again, this is good enough. However, now we need to create an intersection. And obviously, we can intersect two geometries within Dynamo. Within Dynamo, I believe within the modifier, I'm going to go into solids potentially, and solids. And I believe it's in modifiers, if I'm correct. So we have a thing called intersect all. We have intersect, get the intersection of a geometry for this object and another. And we have an intersection all. And I like the second part, just because we can get the intersection of a geometry for this object and a collection of other geometries. So there we go, this is exactly what we need. So I do have my geometry that I want to intersect all. However, I can see I have my levels, and if I plug in my levels, I'm not going to be able to get anything out of this, because a level is not a geometry. But we do have the elevations for them. So what I can create instead is we can create another geometry. But instead of creating a mesh or a surface, I'm going to create an abstract one. And I'm going to create a plane. I'm going to create a plane by origin normal. So usually this is just surrounding a point. And there's going to be a vector associated to it. The vector is going to be by default the z-axis. So it's going upwards. This is exactly what I need. And obviously I'm missing some things here. So what I can do is I can create a point. So to create a point, I'm going to create a point. And I'm going to create a point by the x, y, z. This is going to be my z value. My x by default is 0. My y is 0. So I'm going to leave this blank. So now I have these points. So if I run this, you're going to be able to see I get my points. And I inherited all these z elevations from my levels. So I've now created a bunch of planes. If I see this in my background, I don't see anything at this stage yet. The planes are not appearing there. But I could do this because I haven't created any planes. We can kind of see that I've created these planes now. And obviously this is taking a little bit more space. But we can see these planes all over the place. They are factual, but they are infinite. So it does create that aspect, and now we can actually go and get the intersection. So now if I run this, it should work. So why don't we work? Oh, I didn't extract the geometry out of this one. So remember, this is still not a geometry. We do have a geometry here, which is good. But the only thing that we haven't done in this step is I need to go within my element and I want to extract the geometry out of my element. By getting this geometry, I'm able to use this geometry. And now we get an intersection. It's providing us with an empty list, but it does provide us with something. So there is an intersection. The only thing that I haven't done is I'm not interacting with you can kind of tell I'm interacting with my level 2 list because I only have one result. So I have to just modify this and use my level 1. I want to interact with each one of these individual points, and now we can kind of see we get a bunch of results. These are empty lists, but they do provide where we have intersection. So some of them are not because we don't have anything. However, when we do have intersection, we can kind of see that we get this. So there is an intersection at these. So the only thing that I need to do left here is to flatten this. And we can kind of see where we're going with this. So once again, once I flatten this, we're going to be able to extract exactly those surfaces, which is great. So once again, I'll flatten this out. And we're going to just take a look at some of these things. Once again, I will have an issue. I am going to have to flatten not my level 1 lists, but I'm going to have to flatten my level 2 lists. There is a reason for this, and obviously we have to understand how it behaves, but I have to look at this from a standpoint like this. So obviously, once again, I'm using this to extract the levels that it's interacting with. So right now, if I did my level 1, it would just extract the surfaces because the other ones are empty, so it's just not placing empty values. However, now, because we're going to level 2, it's telling me that it's an empty list, and then when there is something within it, it's going to show me that surface. Once again, we've done this in the other exercise. I'm just going to look if my list is empty. I like this. The reason why I like this is because I can double check and get trues or false based on that aspect. However, I'm attacking level 1 levels item again, so I just have to modify this to get trues and a bunch of false. So basically the falses are what's interacting. So those are the level that are interacting. I'm going to use this to filter my levels. So once again, if I filter my levels based on this mask, and I can kind of see my levels here, I'm going to connect them. I should have my levels that are interacting. So my in list, these are the ones that are not interacting. And the false values, these are the ones that are interacting. And we can kind of see that this is most likely interacting with the upper floor. So we see level 10, 11, 12, 13, 14, all the way to the amenity floor. Great. This is exactly what we need so far. So now what we want to do is we need to kind of extract additional things. So once again, we're going to need to create new columns. And if we remember well, if I go within my structural framing, I'm going to be able to find column by curve. A curve requires a start point and an end point. Here we have start points and end points, which is good. No, actually here, my apologies. So we have these are start points, but we don't have the end points, and the end point would be usually the floor above. So if I'm taking a look at level 10, well, the column on level 10 is gonna span from level 10 all the way to level 11. So we could assume that my start point would be this, and my end point would be this. And then my second column, it would be the next in line. So level 11 would be my starting point, and level 12 would be my end point. So we're going to need to do a few things. So not only are we going to have to extract this, create a new list, we're going to also have to reduce this list so we can actually extract a lot of them. So once we get to the amenity floors, for example, we can kind of see here on my page, and we often have to work this. So we can see here we have a mechanical floor. However, it's not flagging that a mechanical floor. And the reason why it's not flagging is because my column is stopping short of that intersection. So I'm going to have to figure out how to read the floor above too and add it to the list. And I'm going to create my points later on. So obviously a couple of things that we need to do. First and most, I need to get the location of this geometry, of this model component. So let's take a look how we can extract this geometry. I mean, it's going to be very important for us to be able to extract that geometry. So obviously we want to be able to do so. Usually to do this, we're going to go within element. We're going to go modify an element, and I'm going to get the location of this element. and we have this element. I want to be able to extract the location. So now you can kind of see I get a X, Y, Z, but the Z is a 0 value. I don't need the Z value. I'm going to inherit those Z values from the levels. So what I need here is I need the X value and I need also the Y value. So that being said, I'm going to go into my geometries. I'm going to go into my points and I'm going to go point and I'm just going to extract my X and Y. So once again, two beautiful things that we can do is I can extract these. And now we can kind of see I got the extraction of these 2 points, which is exactly what I need to, because later on, I'm going to need to place those columns based on what we've discussed there. So we need a curve, we need a level, and we need a structural column type. In this case, we do have a column type. I know what it is, but we're going to have to extract it once again. I want to be able to replace this. So once again, I want to be able to extract this. So to do this, I'm going to go within Revit. And I'm doing this the long way. Usually I would just right click and type it out. But for the sake of argument, just so that people can learn, I'm going to explain this the long way. So when I go with an element, I'm going to go with an element again. And once again, we're trying to get the specific elements. I want to be able to get the element type of this element. So that being said, I'm just taking this element, I'm taking this element type, and we can kind of see I have my family type. So later on, when I create my column, I'm going to connect this to here, right? So the structural column type, this is the structural column type. It is a family type. However, it will be applicable here because it's a structural column type. I could do this the manual way and select it and just go within my selection and then choosing which one I want, but I want to extract the ones that I'm choosing. So it's just changing the component with the same component. So that way it's going to become that exactly at the end. So now we need to get a couple of things. And this is going to be one of those things. So we have the outfloors. Great. This is one of those things that we can use. So once again, let's get the elevations for this. Kind of like what we did before, is we need to get the elevation marker. So I want to just click it here. And I'm going to use my outings and I'm going to extract the elevations here. So now we can kind of see that these are corresponding to the elevation that we see here. These are my clashing levels. However, I am missing one. Remember, we need to create points. I'm going to create points by coordinates. So I have my points here, the ZY. I'm also going to have my X and Ys. So this is great. I'm able to create a bunch of them like this. If I run this, you can kind of see I'm creating all these with different markers. So I get the X, Y, and I get also the Z. So this is to ensure that later on when I create my structural framing, the column specifically, I'm going to be able to use these markers as my starting point, which is great. However, when I get to the last level, we have now an issue because how do I get to my last level? Obviously, the first one needs to connect to the second one. So what does that tell me right away? Is that I need to extract potentially. I need to drop my first item. So obviously, on my second list, my starting point that's related to my end point, my second point here becomes my end point in the first place on my second list. So what I'll do is I'm going to use a node called rest of. So usually this removes the first item from a given list. So if I take my out results, you're going to see I'm going to extract specifically this one. I mean, I could have done this and bypassed it and just used the elevation marker, but I'm going to do this the long way. Later on, we can optimize some of these things. And you can kind of see that before I do this part, so this is my lines. Later on, I'm going to create a line. The lines are very simple to create. I have a line by start point and an end point. So these are going to be my start points. And later on, I'm going to connect these two curves. So once again, I have my levels that I'm using. The levels that I'm using are going to be my out. And And the last thing that I'm going to use here is I'm going to connect these lines to my curve. But I'm not done yet. I have my start points. I don't have my end points. However, we're missing one level. Remember, we have the mechanical floor. Now, I'm not a big fan of choosing things manually. I want to be able to select things. So what I want to do is I'm going to select my last item here. And once I select my last item here, you can kind of see I get my level floor amenity. And now the special thing that I can do is that I can look for things. So within a list, I can inspect the list and I can get the get item at index. This is not what I want. I want to get the index of an item. So returns an item from a given list that's located at a specific index. We're going to be using this later on, but first I want to get the index of this item. So there is a node and we're going to find it. If I can, it would be even better. I thought it was in the, it shouldn't be in the organize. Should be in the inspect. So it determines if a given list, this function searches to the sublist. It's specifically almost this. Index of, okay, returns the index of the element in the given list. So basically what we're doing here is I'm telling it, go find this element in my initial list of all my levels, right? Here we have all the levels, so I want to be able to find this specific item in this list and tell me what's the index of this item. So if I run this, it's going to tell me 28. Great. So now we're going to do this magic equation. We're going to do x plus 1, and this is going to become my new index, and I'm going to get item at index. I'm going to get one above, right? So once again, I can do this flawlessly. And we can kind of see we're almost here. Once I click this, you can kind of tell that I'm getting a null result. And I'm going to see why, 29. Oh, the other way around. So this is my index. So now we can kind of see we got that mechanical floor. If ever it was a different aspect, a different column, it's going to do it automatically. So now the only thing that I need to do here is I got my starting points, so I'm working on my endpoints. I need to add this to my list. So usually I have a node that says add item to end. So if I add this item to end, I'm going to be able to take this item and I'm going to be able to take this list. And I want to get this new configuration. And now we can see we got the last level. So now we're matching exactly the points that we have. We have 11 points here, we have 11 points there. So the only thing left to do is we're going to copy paste this and I'm going to plug in these elevation instead. So now we have a bunch of lines and we can kind of see these lines here just beyond the column. If I ever want to visualize these, I can always visualize them by going watch 3D. I would be able to plug this in and to kind of visualize this from a bigger aspect. Am I able to get to that? Zoom to fit. I'm not able to get to those lines, unfortunately. Did I run my script? Nope, it didn't work. Yeah. It did create my line though. So in reality, it should be able to create this. Now, the only part that I don't like is when I create my component, I'm going to be left with my old component. So sometimes you want to use this, and let's just clean our node a little bit. You know, it looks like a big giant maze. But in reality, we should be able to create it, and I can. If I run this, we can kind of see that we have now individual components. And if I hide this, I still have my old component, which is, you know, somewhat okay, but not okay. What I don't want to have is I don't want to have both components. So what I'll do is I'm just going to Dynamo script return. I want to just have my basic ones. So the last thing that I can do is I can do magic. I can tell Revit to delete items. So I can go with my element, and I can delete my item. And at the beginning or at the end, whatever, I'm going to be able to take this element, the one that I've selected, and I'm going to delete it. it's still going to send it to the other geometries, but in parallel, it's going to delete it as well. So now in reality, when I run this script, I should have brand new columns. And now we can see all of my columns are spread evenly across the floors. Because these are structural floors with structural columns, they're going to break right away. Even though I'm going all the way to the level 1, they're not going to reach level 1. But the only difference is I'm going to have now a more manageable aspect. So we can do this with any type of component, which is the advantage. So now we can just save this script potentially, and I'll call this revision 1. And obviously it does provide us with a bunch of things and a bunch of levels. So if I close this, if I want to go back into my level, now we can visualize I don't have this problem anymore. And I'm able to do this across the board. The only difference is I would have to scale to select all my columns. And it would do a much more intense, but I like to control these individually. Just because sometimes they're not the same profile, they have different shapes. They could be changing slightly. We can see them also for walls as well. So obviously there is going to be a little bit of work. These are columns, luckily for us. But for most part, we have columns. So we would be able to do for all the rest of them, but we can see a very automatic way of doing this one thing at a time. The only thing that I wanted to do again is potentially I wanted to show everybody the script. I did kind of just close my script down, which is not ideal for anybody that hasn't seen it. And I'll just go back through it. I want to go through this. So what we're doing is we're selecting all categories. We're looking at the levels, extracting the level elevations. There's going to be some issues because I haven't selected anything. Maybe I'll just unselect this. Let me just go back to the basic. Shouldn't have closed this. All right. So once we extract this, we're creating a points by coordinates. We're using these coordinates to extract the Z values. With those Z values, we can create a plane. We can intersect the model's geometry with these geometries because a plane is a geometry. The intersecting aspect, we're going to flatten it. We just need to use level 2. We're going to look if the list is empty in order for us to use this as a Boolean mask. We're going to extract the last item, and we're also going to look for the index of a specific item. And we're also going to get the location of our element. And we're going to get the rest of the elements because we need to kind of go back and forth. There is a lot happening here, so once I select it, you can kind of see this is going in multiple places. We get our elevations. With those elevations, we're creating a new set of points. Because we got the elements location, we're able to get the XY for our points, start points and end points. With our start point and end point, we create a bunch of lines. This is going to serve us to create our columns because we need a curve, we need a level, and we need a structural column type. So we're going to be able to create all of that with this beautiful script. Like I said, I'm a big fan of using just basic nodes. I don't want to go into specific packages. It's just that dependency always bothers me. But this is a very good way of facilitating that change. It's a lot easier than having to copy paste and do this across the board. And I used to do this until at one point I told myself no more. Why am I even doing this way? Like, this doesn't make any sense. I've done it once, and then as soon as the new revision came in, nobody listened to my direction that they needed to change this. They lost their BIM manager at one point. I had a lot of issues, and therefore I got tired of dealing with that issue. Often it would be up to me to make these changes because I would be the one creating these for these schedules and doing the estimation part and facilitating all this BIM usage, blah, blah stuff. So obviously there is a lot to it. My apologies, my throat is a little bit itchy. It's late at night, obviously. It's a late night session. However, hopefully you've enjoyed this session with me. And like I said, I'll keep bringing back more. I think in my next episode, we're going to look at formwork. And I do have a major script for formwork because ultimately what we see here, I can analyze each geometry, each face, and extract the area values of each one of them based on the type of component they are. And for example, a slab, it needs to be formed onto the sides, and at the bottom it doesn't need the top part. A column only needs the sides. It doesn't need the bottom part, doesn't need the top part. A wall is going to be the same. So all of these things in perspective, we can actually create a script that's going to get us to that 90% accuracy in terms of formwork. There's a lot of things that we can extract in terms of value, and the more efficient we are down the line, the better it is going to be. So stay tuned for more. If you have any questions, please leave it in the comments below. Subscribe for more, and I'll see you all in the next episode. Thank you.